So now we're ready to talk about the composition of functions, specifically with inverse trig functions and basic trigonometric functions. And they're done very similar to how they would have been in algebra. We'll go ahead and we'll start here on the inside, and I'll bring that down and view that as just the inverse sine. Remember, that's just notational, of 1 over root 2. So similar to the previous problems, we're looking for an angle theta. So our job now is to find theta such that sine of theta equals 1 over root 2. Inverse sine means theta can be found in quadrants 1 or 4. Sine is positive in quadrants 1 or 2. Therefore, our triangle that we draw is going to need to be in quadrant 1. So a triangle now in quadrant 1. And for sine, remember, sine is going to be the y over the r. So for us then, we've got a 1 and a root 2. Recognizing that as a special triangle, this is also going to be a 1, and it gives us our angle of pi over 4. So that pi over 4, that's the theta. So now the second part of the problem, we'll need secant of pi over 4. So again, all I've done is I've replaced the arc sine of 1 over root 2 with what we found to be pi over 4. So now secant of the pi over 4. And we already have conveniently our triangle drawn. Secant, we remember, is the ratio of r over x. So for us, the r value would be square root of 2. The x value would be 1, and therefore the final answer for the given problem here would simply be the square root of 2. All right, so looking at the next example, now we have inverse cosine of negative pi over 3. Similar, we'll go ahead and start here on the inside. So I'll come down and I'll look to see what cosine of negative pi over 3 is. Negative pi over 3 puts us in quadrant 4. So our reference angle is pi over 3, which tells us this is negative root 3. This is a positive 1 and a 2. Cosine of that looks to be 1/2. So I'm going to replace this underlined green cosine of negative pi over 3 with 1/2 and continue the problem. So now inverse cosine of 1/2. This means we're trying to find theta such that cosine of theta equals 1/2. Now for inverse cosine, that's going to exist in quadrants 1 or 2. Cosine is positive in quadrants 1 or 4. So it looks like the intersection would be quadrant 1. So drawing a triangle now in quadrant 1. Cosine, we remember, is the x over r. So for us, we've got a 1 and a 2. Therefore, that would be the square root of 3, and also suggests the angle is pi over 3. So the angle pi over 3 is the answer to the actual problem. So the inverse cosine of negative pi over 3 turns out to be a positive pi over 3.